In this video, I'll be discussing how to run SQL queries within R. As an analyst, being able to write SQL code has many benefits, particularly in the area of work efficiency. As a data consultant, I've seen a lot of people try and fake their way through database work using Excel, particularly using the VLOOKUP function. And while VLOOKUP is a very powerful tool, anytime you have thousands of repeated formulas within an Excel spreadsheet, it's time to start thinking about how to do things more efficiently. By writing your own SQL code, you also get the benefit of repeatability. You can write the code once, and as long as your file formats stay the same, you'll be able to use the same code over and over as long as you need to run the report. And the examples that I use today are going to be a very common thing that you see within business in terms of file structure, where one file has information that's metadata about your file, and then the other file is a transactions type of file that has all of the information about what happened with very little metadata attached to it. So the two files that we have as our example today are an employees file and an orders file. And when I open up the employees file, you can see that this file is very bare bones in terms of its structure. We have one row per employee where we have the employee's ID number, their last name, first name, and gender. The other file that we're going to be dealing with is an orders file. In this case, what we have is the items that were ordered during a lunch, where we have the employee ID, the item that they ordered, the quantity that they ordered, and the item cost. And what we can see here is that within this table, there's repeated values across the rows. So there's repeated employee IDs, there's repeated items, and then we have the quantity that they ordered and the item cost. And what we're going to do in this tutorial is do various processing to one or more of these files. What we can do is we can subset our files, we can create additional data, we can join them together, and ultimately we can answer a wide range of business questions. So within R, the first thing that we need to do is activate the library that allows us to use SQL code. And this library is called sqldf. And what we can do is just activate our library here. And then the next step is to import our data into R. And since both files are CSV files, we can use the read.csv function to create two data frames, one called employees, one called orders. And when we click on this, it looks like what we would expect. If you were to open these CSV files up in Excel, you get a very similar looking output where you have table data, you have rows, you have columns with one row for each value. So the first set of queries that we're going to talk about are single table operations. So if we have just one data file and we want to answer various business questions, we can do so with the following queries. So the first query that we have is probably the most simple type of query that you would run when you're doing analysis. And this is a subsetting query. So in this case, suppose we wanted to select all the employees that are male. We could do so using the following statement. So all SQL queries generally start with the keyword select. And the select word is telling the computer which columns we want to return in our answer. So by using select and then the star operator, we're telling SQL that we want to return all columns. Next, we tell the computer from where we want to read the data. So we want to select all columns from the employees table. And then finally, we use a where clause to say we want to return the rows where gender equals M for male. So when we run this code, we get a new data frame called male employees. And then we can see in the gender column, all of the employees have a gender equal to M. Next, suppose we wanted to get a count of the number of times a first name occurs in our file. And the way we can do this is using summary functions. So again, we're going to start off our query with the word select, but rather than use the star operator, we're going to use just the column first name. And then next, we're going to create a new column that contains the count of the number of times the first name occurred. So we use the count function, we put in parentheses first name, and then using the word as, we're going to name this new column occurrences. And like above, we're going to do this from the employees table. And then we have a new set of keywords called group by. And this is telling the computer that we want to group our data in such a way where the column that we put in the group by statement only has each value listed uniquely. So all the unique values of first name. And again, we're going to, in the second column, we're going to put a count of the number of times that the first name occurs. So when we run this code, what we'll see is each first name, again, is listed one time. And then we can see, since we have a relatively small data file here, the only name that's been repeated is the name Matt, which occurs twice in our file. Every other name occurs just one time in our file. Okay. Now when I open up that file, I realize that there's an employee that's no longer with the company. So if we want to go through and weed out those names, what we can do is just modify the query above with a where statement. So in this case, the employee that's no longer with the company, his name is Rudy. What we can do is within a where clause, we can say where first name and then the exclamation point it equals represents not equals, and then where first name is not equal to Rudy. So if we reran the query, now we can see that there's no name Rudy within our data file. So this is basically how the SQL language works. You have just a handful of things that you can tell the computer what you want. You specify the data file structure that you want back, and you potentially create some columns. And then basically you can say, I want either a summary of the data, or I want all the rows back in an unsummarized manner. Suppose we wanted to go further with our data file and we wanted to create a new column of data based on some if-then conditions. So what we can do in that case is use what's known as a case statement. So if we wanted to create a new column in our data file where the value was equal to 1 if the employee was from California or 0 from not in California, we could do the following. So we'll use our select statement again with the star to return all columns. Then we'll create a new column using the case statement. And here I'm writing when first name equals Stuart, then the value equals 1. When the first name is equal to Hila, when the first name is equal to John, or the first name is equal to Salon, all of these values should be set to 1 because these are our California employees. Otherwise, we're going to set the value equal to 0, which represents all other cases except for these 4 first names. Again, we can use our as statement to define what the column name should be, which in this case will be Cali_emp. And we're going to do this based on the employees table. And when we run this, you can see that for Hila, John, Stewart, and Salon, the value for the Cali_emp column is equal to 1, and then everyone else is equal to 0. Finally, suppose we wanted to sort our data. Doing something like this in Excel is very easy. You just highlight all of your data, you pick which column. But if you're already doing SQL code, it's just one additional line to do sorting. So we could take the query from above and we could add a statement at the bottom, which is order by. And the important thing to remember about order by is that by default, the values will be sorted ascending. So if you want to change the sorting order based on different variables, you can use the descending value, which you can see here as DESC. Okay. So we can take the table above and we can say, I want to see the employees from California on the top of the list, so descending by CaliEmp, and the value of 1 is larger than 0, so 1 will be listed first with 0 at the bottom. And then I want to sort by first name ascending, and we don't need to do anything here because again ascending is the default. So when we run this query, you have all the California employees on top sorted alphabetically by their first name ascending. So that wraps up all the types of queries that you may want to run on a single table. This is something that you can do very quickly to do subsetting of your data, create some additional columns and so forth. But the real power with SQL queries is when you can join multiple tables together. And that's what we're going to go over now. So in terms of multi-table operations, there's several types of joins that you can do based on the type of data that you'd like to return. So the first join that I'm going to go over is what's known as a left join. And in SQL language, the left table is really just the one that's specified first. So if you think in the English language we read left to right, it's the same concept here. The first table that you specify is the one that is on the left, and then each table after that is basically to the right. So when you're doing a left join, what you're doing is saying, I want all of the data from the left-handmost table, and then everything that I join to it from the right-hand side, I only want to keep the matching records. So when we join the employees table and the orders table together, what we're going to do is we're going to keep a value for every employee, and then we're going to match the orders to the employees that were at the lunch. And then in many cases, the employees that weren't at the lunch are going to be in the table still, but they're not going to have any values. And it'll make a little bit more sense once we run this. So we run our join, our left join, and what we can see is Matt G was at lunch, so he has values for all sorts of sushi items. Jason was at the lunch, so again, he has sushi items. But then when you get to Hila, there's only one row with a series of values of NA. And within R, NA represents null values. So when we're doing a join by ID, for the people that have no match, ultimately their values are going to be blank. And then for LaShonda was at lunch, and then maybe the rest of us weren't at lunch, and so all of us have values of NA. So again, a left join means we return all of the data from the employees table because it was listed first, and only the matching data. If you've used other SQL tools in the past, there's something that's also called a right join, which is ultimately the same concept. You would specify the words right join instead of left join above here, and you would say, I want to keep all the data from the right-hand table, but only the matching data from the left-hand table. It turns out that this package within R doesn't support right joins, probably because it's a redundant function. Right joins and left joins are the same thing, so in order to mimic a right join, all you have to do is switch the order of the table. So in our left join scenario, employees was listed first, so it was the left table, and orders was the right-hand table. If we wanted to mimic that same behavior where we kept all of the data from the orders table, we would just list that first, and then we would do a left join from employees. And hopefully this isn't too confusing, but ultimately you're doing the same thing. You're picking which table you want to keep all of the data from, and then you write the words left join, and then the table that comes after the left join is the table where only the matches are going to come from. So when I run this code, you can now see that we have all of the items, okay, but we haven't kept all of the employees. So we only have the employee information where it matched, but we have all of the items from the orders table. So this would be equivalent to a right join, but we use the left join syntax. And over time, if this is confusing, it'll make more sense as you practice. And that's an important thing as well. The best way to get comfortable with this is do a bunch of practice examples similar to these, so that when you're trying to do work, it'll just come naturally to you. Okay. The third type of join that you can do is what's known as an inner join. So whereas a left join said keep all the records from the left table and just the matches from the right, an inner join says I only want to keep the records where the match occurs in both tables. Okay, so now what we can do is we can do an inner join, and we don't actually need to specify it. An inner join can just be done using a where statement, and we're saying from table A, which is employees, and table B, which is orders, if the ID value is the same in both tables, we want to match them together. Otherwise, we're not going to print the records out. And that's just like a where statement when we were doing for gender. We said where gender equals M, otherwise discard the records. In this case, if the ID matches in both tables, we want to keep the records, otherwise we don't. So when we do this, you now have a situation where you have all of the orders for all of the employees, but you have no additional information. So it's possible that there's employees that are left out of this table, and it's also possible that there's things that were ordered that aren't in the table. Because again, there has to be a perfect match between the ID values. When you're doing an inner join, you need to really be careful that you understand your data because of this situation, because of the fact that the data is only going to return an exact match. But again, an inner join can be a very powerful way to join your data. Okay. So suppose we wanted to do some business questions, and we wanted to now add some where clauses. So suppose Matt G sees the bill, and he wonders why the bill was so low, why people aren't eating more. So what we can do is we can join the orders table and the employees table, and then we can find out the items that were less than $10. And then the same thing, we can add an order by statement to have the item costs sorted in ascending manner. So what we're doing here is a left join where we keep all the we keep all the orders. We then join the employees table to it, and then we're going to limit the table to where the item cost is less than $10. And then again, we're going to sort by item cost as well. And what we'll see here is these are all the records that are less than $10. We see what the item was, and then we see which employee was the one who ordered it. Okay. Now, perhaps this isn't the business question that you wanted to answer. It tells you the item cost, but you can see that some people ordered a lot of quantity. So maybe item cost isn't the right way to understand why the bill was so low. Maybe it matters on a per item basis what is the problem. So we could take the query from above and we could modify it and calculate the actual item level cost. So rather than one piece of sashimi costs $3, if you ordered 6 of them, then the true cost was actually $18. So the item cost times the quantity ordered. So in our query here, we're going to select all of the columns. We're going to create a new column that's called item level cost by doing item cost times quantity ordered, which are 2 columns in our data set. And again, we're going to do a left join. So we're going to keep all of the orders, but only keep the values for employees that go along with those orders. Then, perhaps instead of using $10, we're going to use $20 to say, if someone didn't spend $20 on an individual item for lunch, we're going to single them out in order. So now when we have our table, you can see that we have a new column here that represents the item cost times the quantity ordered. So for instance, with tuna sashimi, 4 of these were ordered at a cost of $2.50 by Jason. So the item level cost was actually $10. Okay. You can see the same situation down here. Salmon sashimi, 6 were ordered at $3. So we have $18 of item level cost. Okay. Now, all of these where clauses and everything work because we're doing a record level comparison. We're just saying in this row of data, if item level cost is equal to 20, then output to the answer that gets returned. But it's possible to do something a little bit more complex where you're using summary functions and then you want to also limit your data. And this starts getting into the area where SQL can become a little bit more complicated. But ultimately the result is the same. We're going to do a summary operation using group by. And when you're using group by, you have to use the keyword having instead of where. So they have the same exact function, except for when you're doing a query that's summarizing, you use group by and having, whereas when you don't have a summary function like sum or average or minimum and so forth, you can just use the where clause. Okay. So in this case, suppose we wanted to find out, instead of looking at things at the item level or at the line item level, we just wanted to find out whose lunch was less than $30. Okay. We would do the same relative join as we were doing before, where we're going to keep all of the data from the orders table as a left join, and then we're going to join the employees data to that table. We're going to group by ID so that we can figure out the lunch cost by employee. Okay. And then we're going to use the sum function to sum the item cost times the quantity ordered. So what we're doing here is saying, for salmon sashimi, for instance, if you ordered 6 pieces at $3 a piece, you would have $18 worth of salmon sashimi. And then for every item in our table, we're going to do that same calculation. And then we're going to summarize this using group by. So this is very similar within Excel. If you've ever used the sum product function, that's exactly what's going on here. With the addition that we're going to have a subsetting clause with having. So we're using sum product if you're using Excel terms, and then you're doing a filter function within our query. And when we run this, hopefully it'll make it a little bit more clear, you can see that all we're going to return is last name, first name, and the total lunch cost. So even though we started out with a table that had every single item in it, now what's returned is just a summary of the total cost by person, and we're only going to return their name. Okay. So now what we can see is Matt W. only spent $7.50 on lunch, Maybe he ate somewhere else before coming to lunch with his coworkers, who knows. And then you have the person that represents NA, and this means, if we remember that NA represents blank, the only time blank occurs is when there's no value. So in this case, we don't know which employee this belongs to. Perhaps, we were taking out a non-employee for lunch, so we have a value of NA. It's important that you, again, when you're doing your joins, that you understand your underlying data. Because if you had multiple people who were not employees, they would all be summarized under NA. And that wouldn't necessarily be correct, because you'd have perhaps 5 people who are not employees. All of their information would be rolled into the one group of last name NA, first name NA. So again, you just really need to understand your underlying data before you jump right into running your SQL code. So finally, I have probably what's the most complicated query that you're ever going to run, and that's because it uses a subquery as the limiting statement. Okay? So suppose you wanted to make a comparison of below average. So find out the employee that spent below average on lunch relative to everyone else. So what we could do is we could calculate the average cost separately, but then we would have a manual component in our code where we would always have to think what's the average cost and then put it in our having statement. But what we can do actually is write a query to calculate what the average cost is for everybody on the fly, and then pass that in as an argument to our SQL query. So what we would do is run what's known as a subquery, and that's that piece that's right here. So we can calculate what the average lunch cost is by doing the sum of the item cost times quantity ordered, and then we can divide by the count of distinct employee IDs that we have. And what this will do is it's going to represent the average lunch cost. So I'm actually going to run this in the interactive module at the bottom, just so you can see what the result is. Okay, so we can see here, I'm just going to add quotes around this. When we run this code, we can see that the average lunch cost for this set of files is $56. So when this piece of the query runs, it is going to return the value of $56, and then the having statement is going to use that to limit the result that we're actually getting back. So ultimately, it's going to be having a lunch cost less than $56. And then for our outer query, which is going to actually be the table that's returned, we're going to have last name, first name. We're going to have the total lunch cost like we did above. We're going to have the same joins that we did before, so we're going to keep all of the orders table, only going to keep the employees where it matches. And then to avoid the problem I talked about before, where we had the NA group in our summary, I'm actually going to use a where statement that says, let's ignore all of the rows at an individual level where the employee ID is NA. Or in this case, the way I've written it is the inverse of that. So we want to keep all the records where ID is not equal to NA or not equal to blank. We're going to summarize by employee ID. And again, we're going to have the limiting statement as having a lunch cost, which we calculate above, less than the value returned by the subquery, which is $56. And when we run this, okay, we have a table called lower than average cost, and then we see there's 2 employees that had a lower than average lunch cost. We have LaShonda at $50.50 and Matt at $7.50. Okay. So like I said, this is probably the most complicated type of query that you'll ever run. And to be honest, it doesn't happen that often that you need to use a subquery. But it is possible to chain queries together in such a way that you get a result from only having to do one query. And depending on what you're doing, maybe that's important and maybe that isn't. So hopefully this tutorial has given you an idea of both what it takes to write a SQL query and how you can do it using R. I think this is a skill that every analyst should possess, whether you do this in R or you use some other tool. Being able to write your own SQL language will dramatically improve the types of analysis that you can do. It will help you save time, and ultimately it will provide you with a way of getting repeatable results so that you don't have to focus on doing the calculations all the time or worrying about errors in Excel. You can focus on the task of actually analyzing your data.